All right, so now let's talk about writing a one-dimensional array in Java. Now, one way to, and there are a number of approaches to do this. One way is to declare and allocate the memory separately. And to do this, we have two steps. The first is step one, which is to declare the array. And to declare the array, we just type out the data type. This data type, again, can be primitive. We've talked about this in the previous video. It could also be reference. You've already figured what the data type is. The next thing is to type the square bracket, the opening and the closing square bracket. Once you type that, you want to then type the variable name. Take note that there is space in between the square bracket and the variable name, and we'll take a look at that in actual program. So don't bother. This is just to show you. This is just to show you how an array is declared. The last thing you do there is to, of course, semicolon. That's the way you end your statements in Java. For step two, you now allocate the memory. And the way to do this is, again, we just look at the variable name. So we say the variable name and then the assignment operator, and we say new and the data type. And we have the square bracket and the opening one, and you have n in between the opening and the closing bracket, and you have the semicolon at the end. The n here represents the number of elements in the array. Remember, we said that you must know the length of your array before you can use them. This is why this is important, because if you leave this blank, and as we'll see in actual program, if you leave this blank, it will ask you what's the length of the element. So you have to specify it ahead of time. Now, let's look at this scenario. You want to calculate the average age of your top 5 favorite friends. The goal is to determine the average age to better understand their age distribution. Now, one approach you might want to take is to say, okay, int age 1 to declare the first person's age, int age 2 for the second person, int age 3 for the third person, int age 4 for the fourth, int age 5 for the fifth person. But the problem with this approach, as you could tell, is that we're repeating things, right? Because we're talking about ages. It's like there's something that we can group together. It's like there's something common with all these things. And you can see that all of them are also integers, right? The only thing is that we're talking about different people's ages, right? But then, what if we had 100 top friends? You don't want to start writing age 1 equal to this, age 2 equal to this, age 3 equal to this. This is where this other approach of arrays is useful. So think of it like this. Rather than have these different variables, why not just have a group? You know, we've talked about arrays as collection, right? Why not just have just one variable called ages? And then we have a group of these other values. We don't know what they are just yet, but we now know that all the ages will be stored in this data structure. And this data structure is what we know as array, right? We don't know what the value is just yet because we don't know by looking at the question. We want to collect this data from these people. But then we can now have ages point to the memory location. Of course, ages is going to be a reference variable. And that's why when we were talking about reference variable in one of the videos, we also made mention that arrays are also inclusive. So let's look at how this would be if we were to write it in actual program. Again, bear in mind, we have 2 steps to take. One is to declare the array, the other is to allocate the memory. And the key questions we want to ask ourselves when we have questions like that is, what is the data type we're dealing with? Because this here, we need it. The other thing we need is the variable name. What do we want to call that, the variable? And the last thing we want to ask ourselves is, this n here, what should it be? And so let's get back here to this example. We know there are 5 people because it says top 5 ages, right? But we don't know anything about it just yet. And so it's all blank at this point in time. But the first question we ask ourselves is, what's the data type? And to know what the data type is, we want to ask ourselves, what are we storing? We're storing the ages of people. Ages cannot be string. Ages are numbers, right? And they can also have decimals, and that makes them an integer, right? Well, we could also argue that they could also be short, but in this case, we'll just say they are integers. And we go to the next question. The next question is, what variable name? For the variable name, you want to ask yourself the question, how can we identify what is stored? What are we storing? We're storing ages in this case, right? And so we want to call this, we want to give a meaningful name to this variable such that when we're looking at it in our program, we know what exactly that variable is referring to. And so we can say ages. The third question, which is the last one, is, what's the number of elements in the array? What's the total number of elements in the array? And to do that, again, remember, we always count at 1. So let's count 1, 2, 3, 4, 5. And now we know that there are 5 elements in the array, and we say yes, we have the number of elements, 5. Now, if we put all this together, we now have this. And data type is int, and so we say int is the data type. We have the square brackets, and we leave space in between. And what's the variable name? Ages. That's what we have here. And the semicolon. The variable name, space, equal to space, new, space, int, which again is the data type. And we have, in between that, we have the number of elements in the array. So this is how we would declare and allocate memory to that array, just to prepare ourselves to then feed in the data. And we'll look at this in actual program. So let's recall again. We have int, the square bracket, ages. The int here is the data type. And so when we initialize or when we allocate memory, what we're saying is the same data type is what we have here. Take note, please. This must not be different. The int there must also be int here. And now we look at the square bracket. That's fine. Good. And the square bracket indicates that this variable is an array. The next one is the ages. The ages, of course, we've said it's the variable name. And it's also the name that we use here when we are initializing the array or when we're allocating the memory. The next thing, of course, is the semicolon there, and that shouldn't be forgotten. But then let's zoom in on the next one, which is ages equal to new int and square bracket 5. And let's look at this new. The new here just says we're creating the array in memory and allocating space for its elements. And what type? We've talked about it. It's an integer data type. And then we have the square bracket. Within the square bracket, we now have the number of elements in the array. I hope this is clear. Another way to do this is to declare and initialize simultaneously. And what does that mean? This same thing we have here, the int ages equal to new int, we can do in just one single line. So we can say int, the square bracket, space, ages, space, equal to new int and 5. And the time we want to use this when we don't know what the values would be just yet. We know the size of the array. Definitely, if we don't know the size of the array, we cannot use arrays. But we can assign the values later, just that we don't know what the values are just yet. And similar to this, we know what the size of the array is, but we don't have values for them just yet. And so we can assign values later. So if that is the scenario, just as we saw before, that you want to collect this data, right? You know the number of people you want to collect data from. You know the type of data you want to collect from them. And you know what data you want to collect from them. So 3 things. 1 is what data you want to collect. 2 is what's the type of data. 3 is how many people are you collecting data from. And these are the key questions. I mean, if you look at that scenario again. So let's look at the second scenario. For the second scenario, we say imagine a student has 5 close friends and their ages are 15, 16, 16, 19, and 13. And you need to calculate the average age of the friends. Probably one of the things that you would think of would be, this is very simple, right? We can just say double age, average age equal to 15 plus 16 plus 16 plus 19 plus 13. Everything divided by 5 should give us the average. And easy peasy, we're done, right? But what if you now want the top 10? You'll now have to start hard coding again. You'll be like, oh yes, I mean, that's not a problem. I have a lot of time to do that. Well, we're programmers. We're thinking of how efficient we can do something, right? But then that's not even the case. Let's say, yes, you were even able to solve the problem doing that. But what if the age of one of them increases in a few days? So again, you have to come look for which of them. You probably would get confused if you look at 16 and 16. You're like, which one? Is it my top 2? Is it my top 3? You get confused, right? And let's say, okay, you're a very detailed person and you don't get confused so easily. You still breeze your way through this. But then what if you need to use their ages to calculate other statistical distributions? So you need to use these ages to calculate something like the mode or the range of their ages. You don't want to start hard coding in every place, right? And so what is it? You might say, oh yes, we can come and say int age 1 equal to 15, int age 2. Now I have a variable. Now I can refer to these variables from anywhere in my code. Yes, beautiful. But then again, remember, we're duplicating things. We don't want to do this. We want to look for a more efficient way to do this. And that's where, again, this array comes to rescue. Now, but recall that in the previous approach, this is what we had, the previous problem. We had this ages, that's the name of the variable. But then we also had this array, but we don't know what the values were, right? For this problem, we know what the values are. And so we say, okay, give us that array, store in it the ages of the people, 15, 16, 16, 19, 13. And then we want to refer to that array, right? What then? How can we do this? This is where we can declare and initialize with the values. So to do this, we do, for this question, we say int square bracket ages equal to 15, 16, 16, 19, 13. And so we just say what the data type is, the square bracket, the name of the variable, and we assign in curly bracket. Take note, this is curly bracket, right? And now we give the actual value in here. within the curly bracket. And so this is what you want to use when you know the exact values the array should contain at the time of declaration. So ahead of time, we already know what the age is. This is different from what we had in scenario 1. For scenario 1, we did not know the age, right? We don't know the age. We were just asked to collect the data from them. For scenario 2, we know what the ages are. Now, we can also use new with values. And the way to do that is to say int, and we have curly bracket, we have evens equal to new int, and in curly bracket, we write out the values. So we can also use this when we want to explicitly use the new keyword along with initializing values. Now, this is also the same thing as doing this, but now we are breaking things up. So if we want to declare on a different line and then initialize with new on a different line, we can do this. Mind you, you can't have separate lines if what you had was just int evens equal to, and you have this. Without new, it's not going to work. So you can't possibly have int evens and then you say evens equal to this. So we'll see that shortly. And let's head over to the environment and we'll see how all these come to play. I'll see you there. Bye.